Okay. Hi everyone, and welcome to DevOps Days Warsaw and my talk, Schema-as-Code, Developer Platforms and Database Schema Changes. My name is Jannik. I'm a founding engineer at Riga, and as part of my job, I'm maintaining two fairly large open source projects on GitHub, one of which being End, which is an ORM for the language, and Atlas, a modern database schema management tool designed to be capable of managing schemas in today's microservice-oriented architectures. Today I want to talk to you about the problem of database schema management. As today we have applications developed in several microservices, all of them having its own database. And then I want to talk about why do schema changes slow down development and how you can use Atlas to integrate safe and fast schema migrations into your developer platform. I guess you all know that some time ago software development was a bit different. We had one single enterprise database, monolithic backends, and most of the time professional DBAs, database administrators, that probably read the whole full manual of the organization's database, and it was their responsibility to manage database schema changes. Today, application development has been split into multiple microservices. Often, each of those services has its own database, sometimes more than one. And those services are developed and managed by autonomous teams, and database administrators are no longer to be seen. We all know that database schema migrations always has been hard, and in today's microservice world, it's even harder. There are a few reasons, one of which there's no standard how you define your database schema and how you execute database schema changes on all of the databases that exist in your organization. There's a lot of manual work required because developers need to manually plan how to migrate from the current version of your database schema to the next version. Sometimes you even deploy those changes manually on your database. There's a huge risk factor, especially with the autonomous team with less expertise. Since there's no DBA anymore, poorly planned changes can cause serious production outage, especially since the database is the stateful component of your system. And operators no longer have one database they have to manage, but several ones. So we need to give them the tools to manage and troubleshoot schema migrations and issues if they occur. So what can we do from the point of developer platform teams? What tools do we need to deliver our application developers so they can be fast and efficient when it comes to database schema migrations? Before I suggest a solution, since it's a DevOps conference, I'm sure all of you know the DORA project, the DevOps Research and Assessment team, which issues a yearly review measuring application development performance. And they extracted 4 key metrics, which is deployment frequency, which refers to the frequency of successful software releases to production. Some even do like 1,000 deployments a day. Lead time for changes captures the time between a developer commits some feature, some code, and this piece of code, this feature has reached a deployable state. This involves sometimes, or hopefully all the time, review of the code, building deploy artifacts, and having them ready to be shipped. Mean time to recovery indicates the time between the detection of an interruption in production and the fix. So we are back and can operate normally. And change failure rate, which indicates how often a team's changes do lead to issues in production. If we have a look at those 4 key metrics, from database schema change view, there are a few things that slow down each of those metrics. For deployment frequency, most of teams, especially teams that have been around for a little bit longer, have shipped code to production that did cause an outage in production. And this has a psychological impact on the team, resulting in a fear of change, because database schema changes that like have an issue in production are hard to recover from, and they are expensive. So this leads to skipping on changes you could have done, small ones, and batching them all off together and shipping this huge batch of change less frequently, which brings down deployment frequency and also, of course, carries a huge, like an increased risk factor, because now you have to deploy several changes at once, and there's a higher chance some of those failures, some of those changes cause a failure. Lead time for changes increases because you have to manually plan schema migrations, you have to manually review schema migrations, and this is most of the time done by the most senior engineers in your team, creating a bottleneck, because now all of the database schema change involved commits have to be reviewed by experts. Mean time to recovery is especially high if there's a database schema change involved. This is mostly because recovering from a database failure requires manual investigation. You can't just roll back as you can with compute and start with a fresh instance of the previous version, because a fresh instance of a database means no data. That's not what we want. You need expert database knowledge on the database that is that has the issue. You need expert migration tool knowledge, because you need to know how to tell your tool which version your database currently is on. And of course, you need expert backend system knowledge because of the microservice architecture. Each service is developed in different languages, different ORMs are used, sometimes plain SQL. And change failure rate increases because autonomous teams tend to be younger, which also means less expertise in the database used, resulting in a higher change, higher rate of failures introduced. So the solution we want to propose is Schema-as-Code, much like infrastructure as code. This means similar like you would do with your infrastructure as code. You declare your schema as you want it to have in this version, and not how you get there. So you don't, as it's already practiced, you ship the instructions on how to bring your migration, the database schema from one version to another version. You just declare how you want your database schema to look like, and let the tooling figure out the way to the new version. You let the tooling verify the new version, and you let the tooling deploy the new version, which leads us to this 4 points, which are the main things we as developer platform teams have to provide our application developers with. Automatic migration planning, which means they no longer have to care about the DDL. They just declare what they want to have and let the tooling do all of the planning. Continuous integration. Let the tool identify issues and rate your migration changes and categorize them in being safe migrations, risky migrations, or migration that will destroy or bring down your production environment. Deployment, modern deployments. You just file your new version and let the tooling ship it so you can forget about it. And of course, monitoring. As I said before, operators now have multiple databases to observe and to manage, so they need the tools to gain visibility into the databases they have to manage. Cool. Now I want to demonstrate how this can be done using Atlas. Can you read this or have to increase it? Okay, cool. Since we want to create tools that work for every teams, regardless of the technology used in the backend, Atlas is capable of providing you with multiple sources for your schema. In this example, I will use a plain SQL file. And in this case, I just declare I want to have a users table, I want to have a pets table. Users have a name, pets have a name, and of course, the pets are linked to the users. All I have to do now is just run one command which instructs Atlas to compute the diff between the current state, which is just empty because this is our very first setup, and the desired state defined in my file. And as you can see, it's basically a copy of the schema because there was no previous version. Now the real magic comes if we want to do things like adding a unique index, and maybe we need a new column, I don't know, hair color. It's an enum, and we have bald, blonde, no, not blind, blonde, and black of hair. And all the developer now has to do is just run this command again, and what Atlas does in the background is replying the existing migration files in your migration folder, computing the current state of your application, and then just inspecting this change, comparing it to your desired state defined in the schema-SQL, and creating the diff. In this case, adding a unique index on the pets table, on the name, and creating a new column for hair color on the users table. Back to here, first point, automatic migration planning check, works. Cool. Atlas is open source and free for everyone, so you can use whatever you like. We have a cloud offering, and I will use this cloud because it has nice visual representations of our. Yeah.
Can we create initial migration from existing database?
Yes. Atlas has an inspection engine, so you can just inspect your current data, and then you have an initial migration file. It's mostly a huge one, but this can be used for the computation of the next versions.
This initial migration will contain only tables.
It will only contain schema resources, no data yet, but we're actively working on.
Function for database?
For Postgres, yes. For MySQL as well. And other drivers we're currently actively working on. Also views and triggers, by the way. Cool. Now, since we are a developer and we want to have continuous integration, which is the next step, we want to automatically validate that our schemas are indeed correct and will not cause a serious issue when we deploy the schema. So the first thing we should do is creating a new branch because we added the hair color, adding our migration. You can see it's checked in and commit it, push it to our Git repository, and create the pull request. As you can see, it contains the changes to our desired state and the way how we get there. Cool, create the pull request. What I have, why isn't it? Okay. What I have set up before is a small, are you familiar with GitHub Actions? I guess all of you are. And prior to this demo, I set up an action which is called migrate lint, which does exactly what we wanted to do. It will analyze all the changes we just committed and then give us a nice report of potential issues that can come from this. So it's currently working. This takes some time because it has to spin up in my SQL database for backend. But this works as well on the local machine of a developer if he wants to. This means lint the latest migration file, and -w means open the web, so we have a nice visual representation of what is shown. And as you can see here, there's one issue actually, because we added a unique index on the name column of the pets table. And if you already if your pets table in production already contains data, there might be duplicates on the name, resulting in this particular change to fail, which can have a mismatch between your compute and your database, or it fails the whole deployment process, which is not what we want. But this is just a warning, since we might not have duplicates, so this migration might go through without any issue. Cool. Our GitHub action, as you can see, is done as well. It's a nice comment, and it will basically give us the same report as the command line did. Same record found. Cool. Now we can merge this pull request. And what it does now is the second part of this YAML file is pushing the migration artifacts to the Atlas cloud. This is an optional step, but it requires, or it enables us to have one central state control for the migrations, in this time Atlas cloud, which we can see here as well. We have this migration directory. It's currently empty because we have to wait for our code pipeline to run through. Once it has, you can think of Atlas Cloud as similar to Docker Hub, but instead of pushing your containers there, you push your your migration. Or you can read the state from there when you deploy, which I will demonstrate in a bit as well. Okay, it has run through, so if we refresh, we can see now we have 2 new migrations. The first one being the first one we issued before, and the second one is the one that created the hair color column and added the the index on the name. And as you can see as well, we have a nice ERD, so we can see the changes between each of the states of your migration of a database schema. Cool. I want to demonstrate now how we can use, since we have now we have the continuous integration part checked as well. Next one is modern deployments for our database schema changes. I have set up a small Kubernetes cluster on my local machine using Minikube. And the first thing I have to do is installing the Atlas operator. What you can see here is that I already have a MySQL container running. In production, don't use Kubernetes, use RDS or whatever, of course. But for this demo, this is nice enough. Since we installed the Atlas operator, we have a new resource here, which is the Atlas migration, which we will define in a bit. As you can see here, there's this new resource kind Atlas migration, and it has a few fields. First one being the URL of the database we want to manage. These are just cloud credentials, so we can sign up or authenticate against Atlas Cloud and pull the migration directory from there. And this is information about the migration directory. It's called app, as we can see here as well. There we go. The one we just pushed is called app. Cool. So Atlas operator should be running. Okay, cool, all is nice. So what we can do now is just apply our changes. And as you can see, it created the Atlas token secret, MySQL secret, and also the okay, it did not. Okay, now it did. And we can see Atlas migration now has a new entry. And if we have a look, version, whatever this timestamp is, was successfully applied. And this one is the version we just pulled from the Atlas cloud. And if you don't believe me, we can actually have a look. we can describe app users, and you can see here there's the new column, and also for the pets there should be the field the migration we just added. Cool. Check as well for modern deployments. Last step, monitoring. Okay, since we used the Atlas operator and the Atlas operator was connected to Atlas Cloud, we have a new entry in the deployments, and we can see now here what the operator did. It created or ran the initial migration, which could have gotten from an inspection of a current database as well, and the new change we just emitted and some useful logs. And this will work for multi-tenancy as well. For example, if you have multiple targets for the same migration directory, the Atlas operator and Atlas Cloud are smart enough to stitch all of them together and know which migration directory was deployed, so you have full visibility in what's going on, which deployments are behind, for what reason, and also some info of how you can fix it. Cool. Any questions so far regarding this? Yes?
How Atlas react when we add some incompatible change? For example, when we add constraint, not null field. You know, previously you have non-obligatory field. Right now you change your schema and add not null
Yeah.
field. And you have to, fill out your database on
Yeah.
data.
Okay, so the question was how Atlas does handle, for example, adding constraints, like having a field not null anymore. Previously it was nullable. So the first thing is continuous integration will catch this and warn you. So you have, or you can, add or edit the migration file and do some backfilling, whatever you need. Second of all,
Manually you have to create some migration to create some fake data, for example.
yes.
Use some function to create this data.
Yes, exactly. If this is not catched in continuous integration because you haven't set it up or you just decide to ship it, Atlas is actually wrapping every change in a transaction and rolling them back automatically if there's an error. This, of course, some databases, for example, MySQL, they have implicit commits. So if you start a transaction and do some changes, MySQL will implicitly commit after, for example, an alter table statement, so it's not able to fully roll back. But Atlas is smart enough to detect this, and once you try again, it will just pick up where it left off, and so you have the change to actually manually still fix it. But this is in my next slide. We want to have, since we have the Schema-as-Code approach, and all of this just comes out of it, we can also actively propose changes that can fix things like this, how you can backfill data. There was another question? Yes?
How secrets delivered or stored in Atlas Cloud? Because you need to manipulate these databases, so
Yes.
secret or access token.
In this case, it was just a Kubernetes secret that's never shared with Atlas Cloud, but it's only on the Atlas operator. So the Atlas operator runs inside your Kubernetes cluster, so it has like network access, and it has a secret to access the database. What we're currently working on as well is having an agent that you can run in your infrastructure that can talk to the database and talk as a middleman to the cloud. This is what's currently in development, is already in testing phase internally, and will hopefully be released next week.
And what about Terraform provider?
Yeah, we have a Terraform provider.
And how it's described in CL language, like database access in Terraform?
In Terraform,
For your provider, yeah.
you can have, for example, some HashiCorp Vault and pull the secrets from there, or just in any KMS, I don't know, AWS, whatever. There was one question, yes? The application is multiple replicas. Yeah. Yeah. So it's basically some kind of blue-green deployment, right? So you have still running the old version until the new version is fully up. We don't have a solution yet, but it's in my next slide as well. So I come back to this. Okay. So looking back again at the DORA metrics, did we have a positive impact on deployment frequency? I'd say yes, because the fear of changes is vanished, because we can trust our CI to detect dangerous migrations and warn us about them, sometimes even block. We no longer batch changes because we are confident that we can deploy them without any issue. So our deployment frequency is up. Lead time for changes. For most of the changes, we no longer need manual review because we have the tooling for it. And also, there's no longer manual planning involved because our tooling does the planning for us, and we just declare what we want to have in our Schema-SQL or ORM or whatever you want. Mean time to recovery. Atlas has an inspection engine, and also since it has the stiffing engine, Atlas is capable of inspecting whatever state your database is stuck in and provide you a way to whatever version you want your database to be at. So this is also like not increased but decreased the mean time to recovery because the manual work is less. And lack of database expertise. Your team itself might not have more expertise than before, but it has the tooling to it has the tooling now, so it doesn't need the knowledge. Future work. Decisions can be made based on the target database state. This is especially for data-dependent changes, for example, adding a constraint. And if we have the agent I talked about running in the system, we can actually do some heuristics on the data and see if we need to, if this specific database-dependent change is safe or it isn't, without like having access to the data directly inside the cloud or on the developer's machine, because the agent in the middle can do this. Data migrations, which also falls in what you said. Sometimes we have changes that require migrating the data in the databases as well. And we are actively looking and researching and having some solutions internally already to help with this. For refactorings, multi-stage migrations, which means if your API changes between downstream consumers, your application and the database in between, it sometimes requires to have multiple stages for a deployment. So you can, like, running for a short period of time on 2 versions until you have fully migrated every piece and can do to the next. And this can also be done by using the declarative approach of Atlas or Schema-as-Code, since we have all we need in the code alongside our application code. And lastly, advanced migration strategies. For example, online schema changes without any downtime, or at least the little downtime is possible. Cool. Any more questions? Yes.